Yeah, success.
Okay. Yeah. Hello, everyone. I would like to thank you for attending our Fluke Networks webinar today, where we will talk about will my fiber support the application I have today? Would it support the application that I will use for tomorrow? So it's a general topic. Okay, we will have a lot of discussions under this topic, and I hope you would enjoy our presentation. So for today's agenda, first we will talk, will my fiber support the application I have today? So it's a little bit different than what we used to talk in our previous webinars, where we focused on our discussion. Why do we need to certify? Is to make sure that the installation has been done properly. So today we will talk about different application or different use of our certification tools, where I can use my testers and the certification tool to test against an application. So today we are all living in a world of digital transformation. So many companies and many organizations and many governments are focused on the digital transformation. So if I have an existing fiber installed, it might be before 10 years, 5 years I installed my fibers, would it support the application which I need for the digital transformation for today? Shall I replace it or reuse it? Can I still use it? So we know that we installed kilometers of fibers in every enterprise. In every, it has been years where we are installing fibers in our application. So can I still use it, or I need to replace it all? And would it support the application that I'm looking for tomorrow? So the digital transformation is not only related to what I need for today. There are plans, what I might need in the future, what I might need for the next year, for the year after. So all of that can be really planned to make sure that my existing installation is meeting the application. And even for the new installations that many system integrators are doing, you might receive a question from the customer or from the end user, would it support the speed that I need today? So to answer that, it's much easier in copper, and we will explain that. But in fiber, it's a little bit more complicated, and we will explain it in our next slides. We will talk about the inspection and cleaning as any fiber presentation. We will not go into deep details because we had a dedicated webinars where we talked about inspection and cleaning. So if you did not attend that webinar and still interested, please contact us and we will guide you how you can watch the recording for the inspection and cleaning. Then we will talk about the multi-mode fiber, because many of enterprises, okay, as you know, multi-mode fibers are used in short distances in enterprises. So we had installed plenty of these multi-mode fibers through the years. So we will talk about what's the limitation, which fiber I can use for my today application or my future application, how we need to test it, how we can verify what's the application that my installation will work with. Then we will talk a little bit briefly about the single mode fiber. And then we will talk about some trends, the future trends, some new applications, some new encoding that can help us to work with our existing fiber that it's already installed today.
Salah, sorry to interrupt you here. The poll questions are available, so whenever you want.
Okay, yeah. So maybe we can start the poll question now. Yes. So we'll wait for 1 minute and then we will keep the poll question and I will go through the presentation. So it's just a general question, general poll question, just to see what the experience that you have today with fiber. So are you using it frequently? Do you have medium experience? You have high experience? Are you expert? And just I would like to highlight, if you have any questions during the presentation, please make sure to type it on the Q&A tab, and we will do our best to answer it on the end of the webinar. If we are not able to answer it, we will send you the reply by email on your question. Okay. So I will keep the poll question, keep answering that, but we will continue in our presentation. So first, as in any fiber presentation, we are always talking about inspection and cleaning. That's a must in any fiber presentation, and we will remind you in one slide, what do you need to do? If you're interested in more details, as I said, please go back and listen, ask us for the webinar recording where we talked for 45 minutes in details how you need to inspect and how to clean your fiber. So please always use a video microscope if you want to inspect your fiber. Don't use your eyes for inspection of fiber because you will not be able to see it. It's very small dirt that it can come to the fiber and it can damage your own eyes if you look at live fiber. So please always use a video microscope. It can be attached to our Versiv platform. You can have a dedicated inspection tool that you can use like the FI3000 or the FI500. Please, even if it is brand new out of the bag, please always make sure to inspect. It doesn't mean that it has a dust cap, that the fiber is clean. Always make sure to inspect it. Always make sure to clean it once you do the inspection. Okay, so this is what you will see with our video microscope. As you can see, it's very small there that it will affect. If we are talking about single mode, we are talking about 9 microns or 50 microns in multi-mode. It's very small. You will not be able to see it with your own eyes. So you need a microscope. If it is dirty, make sure to clean it. After cleaning, inspect it again because it might be that another source of dirt came to the fiber. So please make sure to clean it after the inspection. So I will not talk more about the cleaning and inspection. If you have any question, please come back to us. If you are interested in more details how to clean it, please send us an email and we will inform you how you can watch the recording. Okay. Yeah. So let's talk a little bit about, today we will talk about how to test against an application, okay? Let's explain a little bit what's the difference between the application and the cabling standard. So if we are talking about copper, it's straightforward. So if I'm testing a Cat6a copper and it passes, I can guarantee that the application will work with the 10 gig speed. So there is no difference between testing a cabling standard for copper and testing an application standard. And it's very rarely that you will test to an application standard in copper, because if you test the Cat6a and it passed, then I know that it can work with 10 gig. Same with Cat6. With Cat6 also I can test it. If it passes, then it can work with 10 gig up to 55 meters. If I am testing a Cat5e, then I am sure if it passes, then that it's working up to 1 gig. But that's a little bit different in fiber. So in fiber, we have the cabling standard, which comes under the TIA or ISO. If I test to TIA and it passes, it doesn't necessarily mean that I have a certain speed that my application will work at. So it's a little bit more complicated. So that's why we have a different standard if we are looking at speed of the fiber, what the speed that I can get on my installed fiber. If I'm looking at that, then comes something we call it an application standard, and that's an IEEE standard. If you look at it from its name, it's 1000 base. It means that if I pass this application standard, I will get the speed of 1 gig. If I have a 10 gig base, if it passes, then I will get the 10 gig speed. So what's the difference? In cabling standards, it's a length based and it depends on the number of components that we installed in our fiber. So if I have 4 connectors, or if I have 2 splices, I will have a different test limit than just having 2 connectors or 2 splices. While in application standard, regardless of what you put in the fiber, what did you install in the fiber, it has a certain limit that if you want to have, for example, a 10 gig base, it should have a certain dB loss. So it's regardless of what you install, it is what are the losses that I have in my fiber. If you do not understand it properly, you will understand it in our coming slides. So let's little bit distinguish between the TIA limits and IEEE limits. So if we look at this installation, it can be any installation in the field. As you can see here, I have two connectors and I have a fiber. Okay, per the TIA, if I want to calculate what's the limit, it will be done that, okay, I have two connectors here. So the number of connectors multiplied with the allowable limit for each connector, which is specified per the TIA, which is a cabling standard, it's 0.75. So if I have two connectors, I will multiply 2 multiplied 0.75 equals 1.5. Then each kilometer of fiber, it's having 1 dB loss for every kilometer. Okay, so let's assume that we have here 1 kilometer of fiber. Then my limit will be 1.5 plus 1 dB, and I don't have any splices, it will equal to 2.5 dB. But what if I installed in this application, for example, I did the splices, okay? This limit will change. What will happen if my fiber was more in length? If it was, instead of 1 kilometer, it was 1.5 kilometer, then my limit is changing. So my limit is changing dependent on the number of connectors that I have, the number of splices, and the length of the fiber. So it's a length-based, it's a component-based limit. Okay, so that's the cabling standard, which we refer to TIA and or the ISO. But if we look at the application standard, okay, if we look at the application standard, it can be different. The application standard says, for example, that it should be less than 5 dB, okay, then it will pass my certain application speed. So for this example, we have a total loss that it was measured with our OLTS device, and it was showing a 2 dB. The 2 dB will pass the cabling standard because it's less than the limit, which is 2.5, and it will pass the application, the specific application standard, which is, for our case now, it's less than 5 dB. Okay, so this will meet the speed that what we call it an application standard. Also, it will meet the cabling standard. Okay, but that's not always the case. So let's say this example, okay, it has, if I want to get the 10 gig, then it should have less than 6.7 dB total loss, okay? So let's see an example. Let's see another example. The measured value was 5 dB, okay, it's less than 6.7, then it passes the application, but it did not pass the cabling standard limit, right? Because the cabling standard limit, if we look at the previous slide, it should be less than 2.5 dB, okay? So that's little bit the difference between the TIA and IEEE. TIA or the ISO is dependent on the number. It's a calculation that we do. It depends on the number of connectors, number of splices, and the length of fiber. In IEEE or the application standards, it's regardless of what you install, it should be always less than certain value. It should be less, for example, than 6.7 dB. Then you will get the speed that you are looking for, okay? So that's little bit the difference between the application standard and the cabling standard. And in our previous webinars, we always focused on the TIA and ISO, because if you are installing a new application, if you are certifying a new installation, okay, and you want to make sure that it meets the design, usually we are testing it to a cabling standard. But now, in our application where we want to evaluate our existing fiber, or we want to evaluate the new installed fiber to which speed it will work, then we are testing it to the to the application standard. Okay, so that's the topic that we have today. We will talk about the application standard. We will explain what are the parameters that we should look at in our application standard. So basically, the application standard will take into consideration two things, okay? Two important things, okay? I will hide it, okay? It was because it's a copyright copy, so we should not share it, but yeah, I will hide it now. So if we are taking the application standard, we are concerned about two things, okay? The channel attenuation and the distance or the length of the fiber. So we have a limit. So if we are looking at 10 or 100 base application, if I'm looking only at 10 megabytes application on my fiber, then the channel attenuation for the OM1 or OM2 or OM3 should have certain limit. So it should have a certain value, and the channel attenuation is the same as what we refer to is the actual loss that we are calculating that we are measuring in the fiber. So we have a channel attenuation and we have the supported distance. So it's not enough to pass or to have a better value, the actual measurement to have a better value than the channel attenuation limit. It should be within the limit which the standard specified to us for the supportable distance in meters. So first we will talk about multimode because in multimode, many of the old installations are multimode based. We are still using multimode for short lengths applications. For one reason, if you ask about the price of the fiber multimode and the single mode from a cable manufacturer, in most cases they might tell you that it's the same price. But in terms of cost of ownership, the active components, the receivers, the SFPs, the QSFPs are much more expensive when we are talking about the single mode. So still the multimode, if I have a short distance application, the multimode still have certain applications in our enterprise in the short distances applications. Let's talk a little bit about multimode. The multimode, as we are all aware, it has a 50 microns. We had the OM1, which had 62.5 microns. But regardless if it is 50 or 62.5, it can be both. We will talk about OM3, OM4, OM5, which comes usually as a 50 microns core. So we have a core of the fiber. That's the place where the light moves within the fiber. And then we have the cladding. The cladding, usually it's 125 microns. And the cladding will have different material than the core. Okay, so so we cannot the light will be reflected within the core, so it will not go and pass the cladding. So we will make sure, the cable manufacturer will make sure that the fiber will go the light will go only within the core of the fiber. So this is how we can see the core. This is a picture of how we can see the fiber and the core. But what's the limitation? Everyone knows that the multimode has a limitation on the length that it can support. Yeah, so it's if we can talk about single mode that it can go 300 kilometers, 400 kilometers, that's not possible with the multimode. What's the reason for that? Let's see it in our next slide. So if we have the signal, if we have the light coming from one side of the fiber, if you look, depends on the path which the light will take within the fiber, within the core, it will reach at different times. So if I'm sending the lights, if I'm sending a signal from one side, I'm sending the light on the same time, depends on the path. So if we have this straight line path, we are sure that it reached faster than the other lights which took longer path. So if it takes longer path, it will reach little bit later than what it took if it was going on a straight line, right? So let's look at our multimode fiber. Okay. So we can see that the light reached at different times. So if I'm sending a binary code, and that's what we are doing in fiber, we are sending light off, on, off, for example. So we have this binary code, which is 0, 1, 0. We have it off, on, off. Okay, and we want to transmit it through the fiber to the other side. If I'm receiving it in the same sequence, then that should be fine. Yeah, I transmitted light from one side, I received it on the other side. The receiver on this side will understand that this is off, on, off. Then it means something. Then yeah, so I managed to transmit the signal properly within the multimode fiber, right? But what will happen if I'm sending a bigger binary code? It will be the same also. If it reaches in the same code, if it reaches 101 as on the other side, then it means that the fiber did its job and the signal, we were able to transmit the signal from one side to another, right? But what will happen if we make it a little bit longer? We will have an effect of something we call it model dispersion. So I will send the signal here, off, on, off, okay? I will receive it on the other side on this way, okay? But guess what? The SFPs and the receivers, they can read it. They can still read it. They can understand that from the other side, we received it 0, 1, 0. Even I did not receive it in the same way that it was sent. And the reason for that, because I made my fiber longer. So the light, the longer the fiber, the time difference between the lights will be different. So this, which traveled on the straight distance, would reach much faster than the other lights, yeah? But I would still read it because our receiver can, usually what we have in the market, they can still read it. They can identify it that it's 0, 1, 0. Okay? So this is what we received here. And then this is what we received, okay? But still I was able to read it. But as it goes longer, I would start to receive something like that. And still, the good receivers would still be able to read the signal. It will be able to identify that I have here 1, 0, 1, yeah? But what will happen if I make it more and more longer, okay? I will reach to a limit, I will reach to a point where I will not be able to read it anymore. I will have something like that. So that's the limitation that we have with the multimode, which is theoretically, it's not the same in single mode. In the single mode, I'm traveling in a single line. All the binaries, the zeros, the on, off should reach in the same time. But because of the core, because we have a thicker core in the multimode, this is a limitation that we have. So we have a limitation of the length of the multimode, and it really depends on which type of multimode I use, yeah? And we will talk about it in the next slides. Then we have something we call it a model bandwidth. A model bandwidth is basically what's the volume of data that I can transfer, okay, within a distance, within a certain distance. So if we talk about OM1, okay, I will be able at 850 be able to transmit 200 megahertz within 1 kilometer. If we are talking about 2 kilometers, then that will be 100 megahertz. So it's the volume of data that I can transfer within a certain length of fiber. So if we talk about OM3, I can transmit, I have a model bandwidth of 2000. Then we have a 4700 in OM4, which is similar to what we have in the OM5. And we will explain in the next slide what's the difference between OM4 and OM5. So based on the color, also I can identify if I'm using OM1, OM3, and that's something very important, because if I want to certify and make sure what's the application speed that my fiber can go, it's very important to understand what type of fiber that I'm using. And the colors can help us to identify, but we will see in the next slide that we should not always trust the colors, because it can it can fool us. Okay. So for each application speed, for each application standard, okay, and for each type of the multimode, so for OM3, I can go, for example, for the 10 gig base, okay, up to 300 meters. The same within OM4 and OM5. But if I want to have a 40 gig or 100 gig, then I will have a limitation of 70 or 100 meters. And that's the supported applications that we are using today. We will talk about some application speeds that we can still use. We can have a 200 gig for a multi-mode, and we will explain it in our next slide. So that's future application that we can still have it within the multi. So we talked about the color of the fiber, the color of the jack of the fiber. So all of us knows that if I have a yellow fiber, that's usually it's a single mode, right? But we cannot follow that always, because if we look at this fiber, I can see that it's 62.5 microns. So that's an OM1 or OM2 fiber. It's not a single mode. So don't always follow the color code, because the color code is just a general standard code. But we should always look at the jack or the data sheet of the fiber which is installed to make sure and understand which type of fiber we have installed in our application. So we explained a little bit about the application standards, okay, and what are the limits. So we talked when we want to measure an application standard, we need to measure what's the attenuation loss that we have and what's the distance. And how we can do that? We need to do it with our OLTS measurement. With an OLTS measurement, whoever attended the webinar, always when we start with OLTS measurement, we need to set a reference. We need to make sure that there are no connectors in between when we are doing the reference. So what we will do, we will connect the TRC, we will connect the test reference cords from the output to the input direct from the both sides of the OLTS measurement. We will set a reference. Once we know what's the reference, we will take our measurements. So let's have this example, okay? This will be the measurement that we have is the actual, what's the reading in our OLTS will be the actual loss. And if it is less than the limit which is specified by the standard, by the application standard, and the length of the fiber is within the acceptable limits, the application should work, yeah? So that's the actual measurement that we need to do it. It's the same as what we used to do when we did the cabling test, when we tested against TIA or ISO, okay? So we had a dedicated webinar where we talked how to read the test results, but let's talk a little bit how to read it from the application test perspective. So what's the measured loss? The measured loss, this is the measured loss. At 850, we had 2.13 dB loss. So that's the actual loss that it's measured. It's regardless of which test limit we use, this is the actual measurement of the loss. And that's 2.13 for our example now. What's the limit? The limit is 7.8. And the reason for that, because we selected, in this example, we selected an application standard and we tested to 10 gig speed. For 10 gig speed, it should be less than the total losses that we have in our channel should be less than 7.8, okay? And then we have a margin. So the margin is actually the difference between the limit and the actual loss value. The bigger the margin, the better it is. And it's an indication for us, if we have a big margin, that it might be, if I am testing to a higher speed application, that it might pass, yeah? So we have here a margin of 5.667 dBs. Whether it will pass or fail, it really depends on the limit. So let's take an actual measurement. The actual measured value was 2.13. The limit for this application was 7.8 for the 10 base speed. For the 10 gig base speed, we have 2.6 limit, okay? So it will pass the both. It will pass the 10 gig, it will pass the 10 base because the actual loss that I have here was 2.13, right? But would it pass the 40 gig base? No, because the limit that we have for the 40 gig, if I want to have a 40 gig speed, it should be 1.9, while our actual loss was 2.13, which is higher than. So if I have this result, I would know that my fiber is able to support the 10 base, it's able to support the 10 gig base, but I would know if I have an application of 40 gig that I cannot use my fiber. The solution for that, either to reinstall a new fiber if I have an application that would really need a 40 gig base. So based on this measurement, I was able to identify what's the application speed that I can get out of my installed fibers. Okay. Something very important, even if these values are correct, okay, even if the 2.13 is less than 2.6, I cannot say that it will pass the 10 gig base before I check what's the length. Because if I want to get the speed of 10 gig, it should be less than 2.6 dB. Beside the length, it should have a certain limit. So if I test it, okay, in my example here, the length, the actual length was, okay, 1.5 meters. So we had a fiber which has a length, actual length of 1.105. Okay, how it's measured? Using our OLTS, what we are basically doing, okay, we are sending the light, okay, through our test reference course, through the fiber, through the test reference course, again through test reference course, through the fiber, okay, going to the other side. So we know what's the speed of light, okay, it's physics, we know what's the speed of light. We calculate the time that it needed to pass from one side of the tester through the fiber, through the test reference course, going back. So we know the time that it took, it's calculated. The speed multiplied by time equals to the distance. So we are able to measure what's the distance that we have here. Something to take into consideration that our test reference code also, it has a distance, it has a length. So I'm interested on the actual length of my fiber, and that can be done automatically within our OLTS measurement, that it will subtract what's the length that I have on my test reference code. So it will give you the length of your actual fiber installed in the field. So this is the way that we are measuring the length of the fiber. Once we know what's the length, once we know what's the limit, we are able to know in which application we can. And so now let's talk a little bit about future multi-mode Ethernet applications, okay? So before maybe 2-3 years, 5 years, okay, if we were talking about 200 gig or 400 gig speeds within the multi-mode, someone would tell you, oh, you are joking, yeah, that's not possible. But now it's possible with the help of the MPOs. The MPOs are multi-fibers connected together in one fiber. It has a special connectors. So with the help of having a parallel fiber lanes, we are able to get higher speeds on our multi-modes. It will have a limitation on the distance that we have, but as we go higher with the multi-mode, if we talk about OM5, we'll be able to support usually higher distances than what we are able to have with the OM3 or OM4. Okay, so we have still limitation, but if we are talking about short distance, and I'm looking at very high speeds, if we are talking about 400 gig, It's possible with multimode, but it will be with the parallel fibers. It will be with MPO installations. So if we look at the 400 gigabyte application, if we see SR 4.2, it means that it will run on 2 wavelengths. Okay, so to be able to get it, we need to have 2 wavelengths going simultaneously in the same fiber. So this is something that we have in the market today. Okay, everyone knows about the Cisco bidirectional USFPs. Okay, and we are seeing that we can get a 40 gig on a duplex fiber, on 2 fibers. And that has a limitation now with 100 meters with OM3, 150 meters with OM4 and OM5. And we can transmit and receive on the same fiber with different wavelengths. Okay, we can transmit signals, so we can use 2 different wavelengths. If we are using OM5 and we can still use 4 wavelengths. Okay, so we can get 20 gig per each wavelength, right? Yeah. So we will talk about something that the technology might help us, okay, to have our installed fiber, to have our old installed multimode to work and support and applications that we were not thinking about before. So there is now big discussions and started to be used, okay, or it's coming, that about something we call it PAM2 and PAM4. What's the difference between PAM2 and PAM4? Everyone knows that we are working now with 0 ones, yeah? So it's 0. So if we have a light, it's 0, it's 1. If it is off, if we have light, it's 1. If it is off, if we don't have light, it will be 0. So that's how we are identifying it. So if we are looking at PAM2, or what we call it NRZ, okay, we will have a binary code like this: 1 0 1 0 1 1. Okay, let's take it as this. Yeah, that's what we call it PAM2. If we are talking about PAM4, then we will have 4 light levels. Okay, so what we will have basically, we will have off, which is 0 0, or we will have a little bit on, that what we call it 0 1, or we will have a little bit more on, that we call it 1 0, or full on will be 1 1. So if we have that kind of coding of the binary lights, okay, so what will help us? It will help us to that there will be no increase in the bandwidth required. So we will be able to transmit the same binary code, okay, with up to 1/3 of what we used to do. So this signal, if I want to transmit it as normal 0 1s, I will need to have 0, okay, then I will need to have another 0, then another 0, then 1. But now we are transmitting it in a different way, that within one signal, I'm able to identify that this is 0 0, and this is 0 1, this is 1 0, this is 1 1. And that will have no increase in the bandwidth required, okay? But something that we need to take care of, that reflectance here will be a big noise, yeah? So if we go and we have an application where we are using the PAM4, then we might need to measure the reflectance, and the reflectance can be done with an OTDR measurement. So that's why it would be very important to measure the losses that we have in OLTS, and to measure the reflectance, to make sure that the reflectance are within acceptable limits within the OTDR. Yeah, so I can transmit twice the data in the same time. So look at this binary code, okay? I can transmit it much easier with this PAM4 technology. With the OM5, okay, we can do 4 wavelengths at a time, okay, and that's the main advantage. So if we looked at the OM5 and OM4, okay, we did not see big differences, okay, but the only big difference that the OM5 can use the the multiplexed wavelengths. So we can use 4 wavelengths in the same time. So we can use different wavelengths to transmit signals. And that will be, we will be able within 2 fibers to get a 200 giga speed within the OM5 because we used 4 wavelengths. Each wavelength can transmit 50 gig per wavelength that will guide us to 200 gig on the duplex fiber. So the multi-mode summary, today we are getting 10 gig per wavelength, okay? And this is, we are getting 25 gig with NRZ. Tomorrow with PAM4, we will be able to get 50 gig per wavelength. In the future, the OM3 might support up to 70 meters, OM4 will support 100 meters, OM5 will support up to 150 meters, okay? But the lost budgets will be tighter, and that's something we need to make sure that we are using an accurate way to measure, to make sure we are certifying our fiber for today's and for our future application. We will very briefly talk about the single mode fiber and what are the concerns that we had there. So for multi-mode, we had to measure what's the losses, we had to measure what's the length, and to make sure that it's meeting the applications. But in single mode, okay, we have a 90 micron score, okay, and if I have a light, it will go in a straight line. What does it mean for me? That it can go, I will not have that impact that the light will reach in different times, because once I'm sending the light, all the signals should reach on the same time to the other side because the light is going in a straight line, right? Yeah, so we have different applications. We can go up to 400 gig with single mode applications, especially if we are using the PAM4, okay? So let's see. One of the most important noises that we can see in the single mode is the reflectance. So reflectance, as you can see in the screen, that I'm sending the light, there will be some reflections going to the other side of the fiber. And you know that the active components that we have on the single mode, it's laser, it's powerful, okay? So the reflections can affect my active components, and that's the last thing that I want to see. So the reflectance that we have, it should be limited, okay? And we need to make sure when I'm testing to an application standard in a single mode, I need to make sure that I am testing to reflectance. So again, always when we are installing new applications, we always recommended to use an OLTS measurement to measure what's the losses that we have on our fiber. But if we are measuring the applications, it will be very important to measure what's the losses that we have. Beside that, we need, even if I don't have any issue with my installation, I need to use an OTDR to measure the reflection and to make sure that my reflectance limit are within the accepted limits of the application standard. So this is the trace that we have on our fiber. So you can see here that this is coming from the reflection that we have from the reflections, the number of reflections. So we saw the light was going to one side, reflecting to the other side, then reflecting again. So that was not a signal, that was a reflection from the reflection. And the reflectance, as we said, in a single mode, it's very important for the CRC and the FCS errors. So if I am sending a binary code, if I'm sending 101, I need to make sure that the received will be 1010. And that's what the CRC will give an indication that it's true. And it can, yeah, we can say that the measurement, we can say that the transmission did in the right way. But if I'm sending a binary code of 1010 and I receive it on the other side as 110, that will be a false, and that will have a big impact on the reflectance level that we had on the single mode. So many times we will face this issue if we have a reflectance which is not meeting the application standard. So let's look at it. We have a table, the standard has a table of what's the maximum channel insertion loss, and that depends on the number of discrete reflectance that are typically good reflectance, that they are in the range between the -45 and the -55, and the other number of discrete reflectance, which was little bit not to the level of the first one, so it's in the range of -35 to 45. So based on that, we will be able to know what's the maximum insertion losses that we can get there, and that will be measured with our OLTS measurement. So we will be able to measure what's the insertion loss. If it is below this, then the application should work fine. So let's take an example. We have a link with two LCs, MTP cassettes. So we have 4 total connections. And the information that we have that it's single mode MTP connectors are APC. So they are angled and cleaned. So they should have reflectance, which is better than 55 dBs. And the LC in the cassettes are factory polished. So they should also have better than 55 dBs. So how to know what's the maximum channel insertion loss that we can get there? Okay, so we are seeing that we don't have any bad reflectance measurement. We have 4 connections here. So the maximum limit, the loss budget is 3 dB. So this can be done with an OLTS measurement. If I get less than 3 dB, then that will give me an indication that my application should be okay for the 100 gig base. And this table can be different for the 10 gig, for the 400 gig, okay? So the higher speed that we go, the lower limits that we will have on this table. This table, you don't need to memorize it, you don't need to record it, it's all saved within the tester itself. So it's built in within the tester. So once you select to test against an application standard, it will do the test, and this will be the base how the measurement is done. Okay. So let's take an example. If I don't know what are the reflection, how to read the reflection levels, okay? With our expert module in the OTDR, if I do an OTDR measurement, I will see that the reflection here is 54.08 dBs, okay? Who doesn't know what's the reflectance? The reflectance, it's usually happening when we are having an air gap between 2 connectors. So if I look at this picture, okay, this is the reflectance. I am changing the media. First I have an air, then I have a glass, then I have an air. So this is the kind of reflectance that we are seeing when we are changing the media. So that's what's happening. If I am having a fiber, then I have an air gap that will cause me a reflection. The reflection also can happen if I have a dirty connector. If I have an end face connector, it's dirty, it can cause a high reflection. Or sometimes it can be caused if I'm doing a field polishing of my UPC connector, I might get a higher reflection than what I should have. So the reflectance values, as we said, that's the important part, are now being included in the application specification. And it's something very important to measure in the single mode if I am interested in knowing what the application that the single mode installation would be able to support. How to see it? Within our OTDR, you can see here that our reflection value for the first connector was -54, okay? So I will count the number of connectors, okay? In this application, we had 4. It was within the application limit, then it will support the 50 or 100 gig, whatever I set it up within the tester. Okay, so this is how I can see it. I can see what are the reflection, then I will count it. I see that I have 4 connectors, and then it passes the application. So in conclusion, so you have an existing fiber and you want to make sure, you want to check if it passed the application or not, you need to test it. That's the only way to check if my existing installation will pass a certain application speed or not. What kind of fiber it is, you need always to read the jacket, you need to measure how long it is, what application do you want to support, that's usually it's coming from the IT side, what's the speed that you need. Future application will go faster with multiple colors and parallel fibers, and the reflectance will become more significant. To do that, we need to do an OTDR. Usually, traditionally, we were saying you need to do an OLTS measurement for certification. And then if you have an issue, then you use an OTDR. Nowadays, it might be, if you want to test to an application, then you might need to use the OLTS for certification and for checking the application speed. As well, you need to use an OTDR to check the reflectance limits. Is it within acceptable limits or not? You need, as in all fibers, please, the biggest enemy of fiber is the dirt. So please always make sure to inspect it and clean it if it is necessary. So, yeah.
Salah, good job. We have the second poll.
Yeah, sorry, maybe I was a little bit excited on that. Yeah, but we can take the poll question now because we are concluding it and then we will take the answers. Yeah. So which test limit do you use most often? Okay, so which type? Yeah.
So we will start the question and answers straight after the poll. So if the audience can wait
for 1 minute, and then we can start it. Yeah. So in the questions, nice question that this slide will answer it. So, so we have a question that would the multi-mode fiber only support 500 meters? Okay, so that question can be answered in this slide. We will have the recording after the webinar. We will share it with you, but let's answer that question, which is an interesting question. Okay. Yeah. So would it only support 500 meters? Okay, that's really dependent on the volume of data that you are sending. So if we have, for example, an OM4, okay, we will be able to send a 4,700 megahertz, okay, every kilometer. Okay, if this data is enough, okay, then I can say that I will be able to take a 2,350 megahertz every 2 kilometers. So it's not limited to 500 meters. It's really dependent also on the data that you would need, yeah? And that's why the standard has a recommendation that if you want, then the maximum that we will have today is 300 meters or so if I want to have a 10 gig base speed, then the recommendation of the standard is that it will go up to 300 meters. If 1 gig is enough, then with the OM3, OM4, OM5, I can go up to 860 meters, right? Okay.
I'm finishing the polling.
Yeah.
So while you are there, there's a question also, Salah. Why there are so many colors blue, orange, aqua. Well, can you identify for us why there are these colors?
It's basically to ease the identification of them. Yeah. So one way of identifying it by colors. And to be honest, that's one guy who's doing that. It's me. Yeah. So when I look at the yellow, I would know that it's a single mode. Or if I see a different color code, if I see, for example, here, if I see the pink, I would know that it's an OM4. We should always read the jacket, but for the ease of identification, the standard recommended to use these colors. And I read an article that for military, for example, they are using different colors. Yeah. So, but yeah, that's the reason for having different colors.
Another question related to it was also the cable only mentions 50 and 125. So how do you identify? So the answer is, I think, the same, the color on the outside.
Yeah.
And is there any other way to discover if it's OM2? OM3?
Yeah, actually in the design also, if you go back to the design documents and drawings, it should identify which fiber was installed there. But yeah, but usually the color, if we go with the color, okay, we had a case, we show the case in one example that the yellow was OM2 or OM1, but yeah, but let's say like 70–80% of the time the color will give us good indication of which fiber is installed.
Someone asked, does the connector have an influence on the application limits like LC or SC? Does it make a difference for the application?
No, not in terms, yeah, as we said, in application limit, it's regardless of what you install there. So even in the cabling limit, okay, it doesn't make any difference. The connector, either it's LC, FC, SC, it's specified to be like, for example, in the TIA or ISO as 0.75 dBs. Okay, but in the application, regardless of what you install there, if you install 100 connectors or you do 100 splices, and that's something, yeah, exaggerating, then the limit should be less than certain value. So regardless of the number of connectors, regardless of the type of the connectors, the limit is specified for the application standard within certain value, within certain limit.
So there was a question which you were trying to answer a little bit earlier, which I think we need to answer it again with a brief one. Why we have all these different modes? Why OM1, 2, 3, and 4?
Yeah, yeah, that's very good question. Okay, the different modes of the fiber. Okay, what the industry is trying to do. We are still trying to use the multi-mode because it's cheaper, it's more economical in the installation point of view. And we are trying to get a bigger length of our installed fiber. So that's why the industry is trying to have, like, for example, the OM3, for example, if you look at the 40 gig base, we were able to go with 100 meter. When we installed the OM4, when we introduced the OM4, we managed to do it with 150 meter. So what we are trying to do is to limit the cost of installation, not to go with a single mode, in the same time to have more length of our fiber. So that's why we can see OM3, OM4, and then the OM5 came with a different idea that we will do this wavelength multiplexing in the multi-mode. So I can use 4 wavelengths instead of 2 or instead of 1 wavelength. Yeah?
We have a lovely question here also. Is the application limit, is it fixed value for any application?
Yeah, if we are talking, for example, let's see, yes, we have a fixed value, okay? So if I'm looking for example, let's see this example. Yeah, so if I'm looking at 10 base, then the value is 7.8. So regardless of what I put in the way, it's 7.8, yeah? If I'm looking at 10 gig base, it should be less than 2.6. again, please remember that this is not alone enough, okay? We need to take into consideration what's the length which is accepted within the 10 gig base speed, for example, yeah? So two parameters play a role here. What are the limit as a dB loss as well as the length of the fiber?
Someone had a question around if you measure the same fiber 2 days later, then there is a difference in distance of 6 or 8 meters.
No, that's something, yeah. So it should not, yeah, the device as it has an accuracy, yeah. So if we are talking about, like, for example, if I have a fiber which is like 500, 600 meters, 500 meters, for example, and I'm having a difference of 0.5 meters or 1 meter, yeah, there is accuracy here as any electronic or measuring device, yeah. So if it is within the accuracy which is specified in the data sheet that we have, then we are, it should be okay.
Yeah, so we will check it out. So the person gave the standard they use, the total length, so it's around 500 meter, 5 meter difference in 1 day, it's 1%. If the instrument says it's 2% accuracy, then it's within the accuracy of the instrument. So,
so we will take it, it should not. Yeah, so the measurement is very accurate because it's following the way that we are doing it. Yeah.
So something to add a little bit on this one. I think some people even don't follow the correct guidelines of waiting for the machine to stable its temperature before starting the test. And that could be also another reason for showing different length over the same link. According to our guidelines, you turn on the fiber machine, let it rest for 5 to 10 minutes, stabilize the temperature, and then start. Don't just turn it on and go test it, because the mechanism is not yet ready for the site that you are working with.
True. Yeah.
We have a question. Should we test both wavelength in single mode? And I think the same question could apply for multi-mode. If I have, let's say, on single mode 1310, 1550, do I really need to test on both wavelengths, Salah? And what is the outcome here? What could be the benefit?
Yeah. So different wave. Yeah, I wish I had it in our slide. Yeah. So let's take this for example. Yeah. So it's very important to test in different wavelengths. So we make sure that whatever wavelength is in between this range, it will work, yeah? So usually we need to test, for example, the 850 with the 1300. So it's the device itself, it's always testing on different wavelength unless you make it customized. But yeah, but per the standard, we need to test it on different wavelengths, right?
Question, and I think you partially have it also in the slides. Is there a relation between the bandwidth, the megahertz per kilometer, and the data rate, the gigabit per second?
Yeah, we had it. Yeah, so we had, it has an effect of the model bandwidth. Yeah, so as we go with OM3, OM4, we will have higher model bandwidth than the OM1 or OM2. Yeah.
But you also showed later on that with different pulse modulation, or you can have higher data rates with a lower frequency. So no, there is no direct relation. It depends on the application and which coding is being used.
But if you look also from the application point of view, if you look at the table, so we able to do it, okay? If we go higher in speed, then we are able to do it, but the compromise that we need to give that it will be shorter in length. Yeah? So there is a big relation between, in multi-mode especially, between the length and the speed that we can have.
Yeah, we have a question here. I think it's pretty much related to, we can conform it and related to the application. What is the preference to terminate a connector with a cut and polish or with using a splice? I think this is a very tricky question because it might impact the application speed. So if you have some data to share here.
Exactly, yeah, but yeah, if we look at the splice, the losses usually that you will have in the splice is less. But yeah, in terms of application, it's not always you can do a splice. Yeah, so the connector would be needed, but the connector in terms of losses, always it has higher losses, especially if we are using a UPC type of connectors, because we talked about reflections, so we have higher reflections because it's changing. But if I'm doing a splicing or I'm using an APC, then the losses will be less. So if I'm talking about that, if they have the choice to get a certain speed, like for example, I want to get the speed of 40 gig, okay? And the limit was a certain value. As we said, it's a value. So if I do a splice, if there's a possibility, it would be much better than just connecting two UPC connectors, because I might lose a lot of losses just on the connector. Yeah, but sometimes it's really an open question that it's a limitation that I cannot always do on a splice. I need to have a termination for a reason or another, for a physical reason. Yeah, so but in overall, whatever I install, I need to make sure that it's less than the total loss limit that I have in my application. So it's like building a street, okay? Regardless of the bridges, regardless of the tunnels that we do, okay? It's designed that always you will go with 100 kilometers per hour. Yeah? So it's regardless of whatever we put there, it should be always okay that you will be able to have a speed of 100 kilometers per hour. So it's in the same principle.
I think we ran over the hour again, so there are maybe a few more questions, but
okay. But I would like to summarize it. If there are any questions not answered, we will make sure to come back to you. But I would like to summarize it here that we are seeing our governments in our region having one of their top priorities to do this digital transformation. Yeah? So in many countries, we had discussions with some ministries, and they need some application speeds for their installation, and they are not sure how to get these speeds. Their installed fiber, is it okay or not? And the only way to do it is to test it against an application, as explained in our webinar. So it's very important, very critical. Whenever we are talking about speed in fiber, we need to test it against an application. The last thing that I would like to highlight, we are, as Fluke Networks, we are having a limited time promotion for our fiber. For certain products of our fiber, we have OLTS, OTDR kits, inspection cameras. So it's especially for fiber, we have a limited time promotion which will end on 15th of June. So if you have any requirement or any fiber or your company is interested in having increased number of these fiber testers for your current project, for your future project, please contact me or Wael or Werner, and we will be more than glad to guide you how and where you can purchase our fiber testers. Thank you very much. I would like to highlight that now, because of the Eid holiday coming and the last week of Ramadan, we will have our webinars back after Eid holiday with different topics. We will have some topics about how to do an OLTS and OTDR and the difference between OLTS and OTDR and power meter measurement. We will have some topics about industrial Ethernet. Stay tuned with us, and Eid Mubarak to everyone. See you after our Eid holidays.
Unless you work in medical sector, then we do have.
Yeah, we have one dedicated webinar where we will talk about how to accelerate installation in a healthcare sector. It will be done with our Fluke colleagues. It will not be all Fluke networks. It will be done with Fluke Industrial, where they will talk about air quality and power quality, and we will have Fluke Biomedical, where they will talk about their healthcare solutions and Fluke calibration. So it's a combined webinar where we will have next week a dedicated webinar that's mainly dedicated for the healthcare sector. So if you are working in the healthcare sector, please stay tuned with us. We will send an invitation for our next week webinar. Yeah, thank you very much. Thank you for attending, and I'm glad to see this big number of attendees on all our webinars. Thank you very much. Thank you.
Thanks, everyone.